Hey everybody, David here. So in this video I thought we could talk a little bit about Google's protocol buffers. So that means I'll just give you my little spiel on what they are, show you how to install them and set them up on your PC, and take a look at their performance through some code examples. So before doing anything, let's see how Google describes it. So they say it's a language-neutral, platform-neutral, extensible mechanism for serializing structured data. So think XML, but smaller, faster, and simpler. So that's a pretty perfect way of saying it. You know, it's simple, concise, straight to the point. So why use something like this? So let's just say that you're streaming in large volumes. A heavy cost on memory and performance is going to be the I/O and the serialization you do up and down that pipeline. While milliseconds, here and there may not seem like much initially, when you're streaming in millions of records an hour, saving a few nanoseconds here and there can kind of reap huge dividends, especially when you're on that scale. It's for this reason, in addition with protocol buffers following a language-agnostic, backward-compatible model, that they make for a pretty attractive serialization tool. But when you boil it all down, it's actually pretty simple from a client perspective. The idea is that you take these JSON, XML-like proto files in the shape of your data model. They kind of look like this. You have these key value pairs with some additional proto metadata. And once you have that file defined, you then run that file against the Protcol compiler for one of its supported languages to create a POJO, if you will. Then you use that class to read and write data, at these supposed supersonic speeds. So Google's got a pretty straightforward overview on how to get these things up and running, on its supported languages. But we are going to go ahead and get started with Java. So they'll point you in the direction of their release builds out in GitHub. It's from there that you're going to download the jar that makes the most sense for your system. In my case, it's going to be 64-bit Windows. So there's nothing to install here. It already comes pre-bundled as an executable with some, extraneous files that you should be able to drop and run in from anywhere, just as long as you've got it set up in your class path. So for the sake of consistency, I'm going to go ahead and drop this in my apps folder. And now all we really need to do is update our environment variables so that we can run this guy through the terminal. And so we can do just that. So after you pull up the terminal, you can test it by just typing in protoc -- version. And that should tell you right away if it got in the class path. Can't quite show this in action. I was running into issues when I was capturing footage for this video. Something about a missing import. But the idea is that if you take this command, you can transform your existing address book proto file and just create this monstrosity. Now this is going to be your access class. So now that we've got this sample Java class, let's go ahead and then look at a couple of ways we might interact with it. So these things are immutable, so no changing values on the fly, but they can be built using a builder pattern like we have here. So you've got your toString method, which gives you this beautiful snippet of JSON, and of course you have access methods like you might expect. But let's take a look at how this stuff actually performs. So I've set up a fairly simple load test in which I have a single text file, and that contains about 10,000 people. So after this data is pulled in, I've got a series of methods to test the performance for both serialization and deserialization, against both Java and protocol buffer. So we've got the results right here for a single run. It's pretty telling already, but for a more accurate result, we're going to run this operation 100 times to aggregate those statistics, and then we can really get to dissecting what it all means, which thankfully I've got outlined right here. So basically each of these methods is just going to be running their own serialization operation and then returning a list of times, each represented in milliseconds. You can kind of get a general gist of what's going on here. And then from that point, it's just a matter of printing out some McDonald's-like statistics and compiling that into consumable views. And here we are. Now let's get the boring stuff out of the way first. First of all, it looks like the results remained more or less stagnant when serializing and deserializing the same object repeatedly. And it's pretty subtle, but if you look on the first pass, serialization was marginally more time-consuming before the object leaked into memory. It also looks like deserialization is generally a bit more taxing than serialization. In Java, especially, it looks like that margin is pretty wide. at least 700 milliseconds. So those are the biggest obvious takeaways. Now, without question, serialization using protocol buffers was, that's the real deal. That was far more advantageous. If you look, there are quite a few times that protocol buffer could hardly even fall onto the grid, where it was just in the nanosecond region, while Java always seemed to kind of hover between 250 to 1,000. Now, while the writing's pretty much on the wall, let's just kind of look at this in a more categorized format. And not to beat a dead horse, but protobuf rarely even makes it on the grid. Like, the most powerful values to take away from this, in my opinion, are the max and the mode. And when developing a solution, you'll usually want to test and work with the worst results in mind, as a soft buffer. Because there's a general rule of thumb that when things become really complex and you throw them out into the wild, they're probably not going to perform to the level that you might have thought they would. And with the mode, you've got some reassurance that most of the time, you know what you can kind of expect, right? Even if it was bad, you can consistently be bad, as opposed to it jumping up all over the place and you not knowing what's going on. So we've got a pretty good baseline here. And even using a single file and some static data, which probably skewed the results closer to the bottom end, I still think it's pretty painfully obvious which tool comes out on top. So I showed this earlier, but with some calculations, you can see that protobuf serialization is a whopping 40 times faster than Java, and its deserialization is over 160 times faster. So, if your question is whether you should use protobuf or Java's native serialization library to, increase your performance, and I think you've got a pretty good answer. It's protocol buffers. And, a bit of a disclaimer, I don't want to make this to be the be-all, end-all serialization tool. Like anything else, the right solution to your problem usually depends. And there's a lot of serialization tools on the market. They're constantly adapting. They might perform a bit differently depending on your platform, your data model, your rate of consumption. Then you also have to factor in the overhead and including something like this. It may not be worth it depending on what kind of data models you're dealing with. And just my 2 cents, don't let the paralysis set in either, which it inevitably will if you're trying to cover all of your bases and future-proof your stuff. Eventually, you just kind of pull the trigger and see what happens. But anyway, hope this was helpful. I've got the repo, resources, all kinds of stuff right down there in the description of everything I went over. So just thank you all for watching and take care.